A force of 62.5 Newton is applied to a trolley of mass m kg parallel to the inclined surface as shown to keep it moving down an inclined surface at a constant velocity. The vertical height of the inclined surface is 12 meters, and then refer to the diagram below. A kinetic frictional force of 35.5 Newton acts on the trolley as it moves down the inclined surface. And then 5.1 says write down the name of the conservative force acting on the trolley. So in our context, in our curriculum, we only have two conservative force that we talk about, right? We talk about gravitational force and electrostatic force. Here in this instance, the only force that is acting on this trolley as it moves down the incline at a constant velocity is gravitational force, right? Gravitational force. And we can move to 5.2. 5.2 says let's calculate the work done by the friction on the trolley, right? So fine, we are given the frictional force. Here it is. Here it is said to be so we have frictional force which is equals to 35.5 newtons, right? And then apart from frictional force, we know the height, right? But then from the height we can find the length of the incline, right? How can we do that? We have the angle here, and then we have the height. We can use trig ratios, right? So what we can do, we can say that sine of theta is equals to y divided by hypotenuse, right? But then in this instance, we know the angle. We know that sine of 30 degrees is equals to our y is our height, right? Which is 12 meters. So we have 12 meters divided by the length of the incline. That's what we ultimately interested in. So we can label that as delta x. So it should become easy to see now that delta x will be equals to 12 divided by sine of 30. And then if we do that, we get 24 meters. So we have the frictional force, we have delta x, and then we have the angle between the frictional force and the direction of the motion. So now we can say that the work done by the frictional force will be equals to that force of friction multiplied by the displacement of the object multiplied by the angle, right? So what is the frictional force? We've already said that the frictional force is 35.5, right? We calculated the displacement, that's 24, and then the angle. All the time, frictional force opposes the motion, right? So the angle should be 180 degrees, right? So we have cos of 180 degrees. And then if you punch that in your calculator, you're gonna get minus 852 joules, right? So that is the amount of work the frictional force is doing on the trolley. And then now let's do 5.3. 5.3 says write down the change in kinetic energy when the trolley reaches the bottom of the inclined surface. Let's go back to our statement again. We have constant velocity here, right? We know that the change in the kinetic energy is equals to a half mass Vf squared minus a half mass Vi squared. If we are moving at constant velocity, then Vf squared is equals to Vi squared. So the change in kinetic energy should be equals to 0 joules, right? And then now we can do 5.4. 5.4 says use the work energy theorem to calculate the mass m of the trolley. The work energy theorem to calculate the mass m of the trolley. Here I'm going to use work net is equals to the change in kinetic energy. The other formula you can use, you can say that the work done by non-conservative forces is equals to the change in the potential energy plus the change in the kinetic energy, right? Maybe this is the formula you might want to try out and see if it also works. But then I'm going to use this first formula here, right? So what is the work net? The work net is the sum of all the works done by the individual forces, right? So we have the work done by Fg, and then we have the work done by friction, and we have the work done by the force applied, right? And this is equals to Ek. But we know what Ek is. Ek is 0, right? Apart from Ek, we know the work done by friction. We just calculated it in 5.2, right? So what is the work done by Fg? The force of gravity multiplied by the height, and then cos of the angle, right? Plus the work done by friction. We know that that is minus 852, right? And then plus the work done by the force applied. We know that the force applied is 62.5, right? So we're gonna, let me just write it in the line below. So plus 62.5 multiplied by the displacement, and then cos of the angle, right? And this should be all equals to 0. So let's talk about this work done by gravity first. So there's two ways you can use to find the work done by gravity. You can use the gravity itself, right, and the height. Apart from that, you can find the parallel component of the gravity, and then you can use the displacement, right, the distance from A to B, which is 24 meters. If you also use that, we should get to the same answer, right? But then I'm just gonna use this in this question. So what is Fg? Fg is the mass multiplied by the gravity, right, which is 9.8, and then the height is there on our sketch. We know that is 12 meters, and then what is the angle? The angle between Fg and the change in the object's position relative to the height, right? That angle is 0, so we have cos of 0, right? Because gravity is pulling the object down, and ultimately along the height the object is going down, right? So that angle is 0, and then minus 852 from gravity, and then now we'll have plus 62.5, and then the displacement we calculated it, we know that is 24, right? 24, and then multiply by cos of 180. Why am I saying cos of 180? Because this force applied is pulling the object up, but then the object keeps sliding down at constant velocity, right? So the angle between the force and the direction of the motion is 180, and that will all be equals to 0. So you can see here that the only variable we have that is left is the mass, right? So we have solved the conceptual physics problem. Now we're just solving the math. Before I put anything in the calculator, I'm just gonna take everything that belongs to the right hand side to the right hand side, right? So I'm gonna have the mass multiplied by 9.8 multiplied by 12. Cos of 0 is 1, right? So there's no need to include that. That will be equals to now I'm taking this minus 852 to the right hand side, so it will be positive 852, and then this here, right, we know fully well that cos of 180 will be minus, right? So when I take 65 multiplied by 24 to the right hand side, it will be positive, because cos of 180 is minus. Now we're taking it to the other side, it will be positive, right? So here we're gonna have plus 62.5 multiplied by 24. So now it should be easy to see. We're dividing both sides by the coefficient of m, right, the mass. So we're gonna have the mass being equals to 852 plus 62.5 multiplied by 24 divided by that coefficient 9.8 multiplied by 12, and the mass is apparently 20 kgs.